This is section 4.4, part B. We're going to look at some rational functions that aren't just directly shifts of the graph of y equals 1 over x. We'll be looking at a few things here that are kind of getting you ready for your next math classes. We'll be doing some of the basics, but you'll get a lot more detail about some of these things if you take pre-calculus or even calculus. So, if I've got a general rational function, p of x over q of x, let's start by talking about vertical asymptotes. What we saw here, not surprisingly, was any place that makes the denominator 0, like x equals -2, was a vertical asymptote. Or here, when x equals 1, that's also a vertical asymptote. So in terms of finding the locations of the vertical asymptotes, they're just the locations that make the denominator equal to 0. The horizontal asymptotes are more complex to predict without some higher math. So I'm actually going to give you a list of conditions for those that you don't have to memorize. They'll be available to you if you need them, but you do need to know how to use them. So here we go. Turns out that the horizontal asymptotes depend on the degrees of p and q. First of all, if the degree of p is smaller than the degree of q, there's a horizontal asymptote at y equals 0, the x-axis. If the degree of p is equal to the degree of q, then your horizontal asymptote is at y equals the ratio of the leading coefficients. We'll talk more about that when we see an example. But remember, the leading coefficients are just the coefficients of the highest powered term, top and bottom. Finally, if the degree of p is greater than the degree of q, there is no horizontal asymptote. So we'll be using that chart as a given, and like I said, that's available to you to use during tests. But we'll be using it as a given for now to help us locate our horizontal asymptotes when we graph. Other helpful things that we do know how to find by hand and could include in our graphs: the x-intercepts, which remember we can find by setting y equal to 0, and the y-intercept, which we can find by setting x equal to 0. These are not guaranteed to exist, but if they exist, we find them using the same techniques that we've used in the past. So let's give this a try. In these next examples, we'll try to locate our asymptotes and then sketch a graph. Here's our first function. Let's start by finding vertical asymptotes. The vertical asymptotes always occur when the denominator is equal to 0. So if I'm going to solve that, looks like it's just a trinomial, but I don't have an a of 1, so to work just a little harder for this one, sum of 1, product of -30. It's going to be a -5 with a +6. So I'll split up that middle term as -5x plus 6x. Factoring out of 5x gives me x minus 1, plus factoring out of 6x also gives me x minus 1. Factoring out the common binomial, x minus 1, leaves 5x plus 6, and I get x equals 1, and x equals -6/5, or -1.2. So there are my vertical asymptotes. 1 at x equals 1, and the other one at x equals negative 1.2. So just a little bit past negative 1 here. All right, so those are vertical. What about horizontal asymptotes? Remember that we define P as the numerator and Q as the denominator. And horizontal asymptotes depend on the degrees of those. So the degree of P is 1, and the degree of Q is 2. So we're in the situation where the degree of P is smaller than the degree of Q. That tells me that there's a horizontal asymptote at y equals 0. And so I'll put that in as well. All right, that's as much as I'm going to ask you or expect that you be able to justify by hand. From here, I would ask that you use a calculator or Desmos to actually draw the graph and then just sketch it in around the asymptotes that we have drawn. And here we are, I just shifted us over to Desmos, and I've already got our function typed in. And what you can see, I hope, is here's that asymptote at 1. Here's the asymptote just past the negative 1. That's our negative 1.2. And then you can see the shape of the graph. Oh, you can also see the horizontal asymptote at 0. Now, of course, on the actual computer, because of the number of pixels we have to work with, it kind of looks like the graph is melting into the asymptotes, but we know that truly they don't actually touch. So I'm going to take this picture, and I'm going to switch back over to my equipment or my notes, and I'm basically just going to draw this picture over here. Oops. Hang on, let me take one more look at this. Let's see, we start out going over and down. So we're going over towards the negative side and then down. When I draw, I am going to be very careful not to touch my asymptotes. And again, in between the asymptotes, we go from top to bottom with kind of a little wave in the middle. And then finally the right-hand side, which looked like that. So just a basic sketch is what I'm looking for. Like I said, justify your asymptotes by hand, but then you can use Desmos or your calculator or whatever you'd like to help you fill in the details. We'll learn how to actually predict the shapes of these in future math classes. All right, let's do another one. Once again, we'll identify the P and the Q, top and bottom. And starting by looking for vertical asymptotes. Vertical asymptotes are where the denominator is 0. This one, hopefully, if it factors, should factor a little easier. I've got a nice a equals 1, so I can start by splitting it up as an x times x. And then if I'm looking for a sum of 2 and a product of negative 8, positive 4 and negative 2 should do that. So x equals negative 4 and x equals 2 are going to be my vertical asymptotes. All right, what about horizontal asymptotes? That's dependent upon the degrees of P and Q. And notice the degree of P is 2. And the degree of Q is also 2. So in this case, they're equal. When that happens, I need to look at the ratio of the leading coefficients. The leading coefficient for P is 2. And for Q, it's actually 1. It's 1x squared. The 1's just not written. So my horizontal asymptote is going to be at y equals 2 over 1, or y equal 2. And again, we'll sketch that in. All right, again, that's as much as I expect you to be able to justify by hand. From there, we'll flip on over to Desmos, and we'll use that to graph the function. So my numerator was 2x squared. Oops, I missed the x. And my denominator is x squared. Oh my goodness. Sorry, fumble fingers here. X squared plus 2x minus 8. There we go. So you can see here at -4, it appears that that vertical asymptote is showing. Also at 2. And then at y equal 2, it seems like we could have a horizontal asymptote, although something interesting happens over here. We've gone below y equals 2. We've cut through the horizontal asymptote. That's allowed. Horizontal asymptotes can be crossed. Verticals cannot. If I were to just kind of keep going out here, you'll notice that even though I've gone down below y equals 2, the graph seems to be coming back up and getting closer and closer to it. So if I'm going to sketch my graph, I'm going to start out in this upper left quadrant. Like so. Between the asymptotes, I have almost like a lopsided parabola looking thing, but the vertex does appear to be at the origin. Like that. And then, being a little careful here on the right-hand side, we do go up towards positive infinity near the asymptote. We're going to come down and cross below the horizontal asymptote, and then go back up and approach it. So starting up here towards positive infinity, I'll come down, cross the horizontal asymptote, and then go back up close to it again. Something like that. And there's my picture. All right, I have one more. Here's our last function that we're going to try to graph. And always it's where my denominator is 0 that I'll get my vertical asymptotes. So x squared minus 4 equals 0 will give me vertical asymptotes. X squared is 4, so x would be plus or minus the square root of 4, or plus or minus 2. So I have one vertical asymptote at -2, and another one at +2. All right, the degrees, numerator is always p, denominator is q. So when I'm looking for horizontal asymptotes, the degree of p is 3, and the degree of q is 2. So in this case, the degree of p is greater than the degree of Q, which tells me there are no horizontal asymptotes. So that's as much as I can do by hand. Let's flip back over to Desmos and see what it has to say about this graph. See, I'm going to pause it so you don't have to watch me type here. All right, here we go. I went ahead and just typed into the Desmos the equation that we're trying to graph. And you can see here's that vertical asymptote at -2, another one over here at +2, and then there isn't a horizontal asymptote. It goes down towards -infinity on the left side, goes up towards +infinity on the right side. So we'll try and go ahead and sketch that onto our graph. We're up here at +infinity, and the graph just kind of comes down and goes down towards -infinity on the left side. In between the two asymptotes, we have, again, kind of a lopsided parabola-looking thing. Notice that it does have a couple of x-intercepts. One's at 0.2 and one's at about 1.3. And the vertex is in between them up here above the x-axis. So just to be approximately right, about 0.2 and about 1.3. We've got this little sort of parabola-looking thing. And then we'll come down and approach the two vertical asymptotes. Finally, we've got this little swoop up here, approaches the vertical asymptote here, and then goes up and to the right for the end behavior. So up here by the vertical asymptote, and then up and to the right. I didn't actually make the effort to get the minimum value here correct. We certainly could have. We could have used Desmos for that, but I'm just looking for a general shape right now. So that brings us to the end of section 4.4.